Okay, in this slide, we work with alright here. Now let me review about the loop. About the loop. So think about, you have a program here. You have a program to find out what's the average grade of all students in the class. So this program, you got you get the number of students, right? And for each student here, you get the grade from the input from the user, right? And you sum it up together, and at the end you divide by number of students. You have the average. Very simple program. Think about this one here. You follow the same rule, right? You have the same rule here. This is definite loop. The number of iteration is the number of students here. Right? So see, when you got the number of students here, when you got the number of students here, you have the loop here. You have the for counter in the range of student here, and for each student you get the grade, and you sum it up to the accumulator here. You see, the accumulator is the sum. I set it to 0 before and outside the loop. And I do the same. I do the same with the router here. You see, if you look on the left here, that is the router file, right? And there's a number of students here. I see. I initialize the counter by number 1, right? I initialize the accumulator. Sum is 0, right? So now it run it until the counter greater than the number of students here, right? If not, and the grade for each student, right? Sum it up to the accumulator, right? And increase the counter of students here, right? So at the end, you see, you have the average grade is the sum actually in the divide by student is okay, right? So very simple, this program. Make sense? Very simple here, right? Sum it up and divide for the number of elements in what average. Now I can run this program with you here. I can run this program here. See what this one, right? Think about it. Make it simple. I got the 3 students here only. So for you have the 60, you have the 70, and you have 80, right? So the average grade is 70, right? And the sum here is 120, and the average here it is 70. That's correct. Right? Now, but what happened with this program if I want to go over to check what is the grade of the first student and what's the grade of the second student? Can I see it? Why I cannot see it?
Each time you run the program, it overwrites it.
Yeah, because the thing is that this one here. If you look on this program here, see, if you look on this program for every student, right? You store grade into the same variable here. You store it into the same variable. And the same variable name is grade here. Right? So think about here. The first one you have grade here. You put the 60 here, right? Now the next iteration you put the 70. It overrides the first one. Right? And the last one here you add the 80. It overrides the 70. So basically for this program you cannot go over. You see what is the grade of the first student and what is the grade of the second student. Right? Make sense? Hello, make sense or not? Okay. Because you know that the variable, if you reuse it, it will override. Right? The new value will override the old value. Right? So for this program here, you see, for this program, you have program here. The grade of the previous student will be overrated. You have no way to come back to see what the grade of the first student and the second student. Okay, so how can you overcome this one? What do you think? How can you overcome this problem? If you want to go over to see what is the grade of the first student and what is the grade of the second student and so on. What do you think? Yes, you can think about, I can use a separate variable here. Right? You can use a separate variable here. So we see, I store the grade number 1 for the first student, grade number 2 for the second student, and grade number 3 for the third student here. Right? And anytime I can go over to see what is grade of the first student and what is grade of the second student. Right? But what happened with this program? Think about if you have hundreds of students in my class here, you have to do it 100 times, and you have to store it into 100 separate variable here. It's huge work here, right? So all of this problem here, all of this problem you can overcome by using array. And that's what we learned for today. So what is array? In this chapter, we learn about what are the arrays and how you create and load data into array. And you learn about some application of the array here. Some find out sum and average on the number, find out the minimum and maximum number, how an array can replace a netted addition, and so on. Now, understand about the array. The first definition here, understand about the array. What is the array? What's the array here? Array is a series or the list of variable items stored in the contiguous memory location. So basically, when you work with the array, you have the multiple element here, and they put it next together in the memory. So when you put next together, the way you read it very fast here, instead of the random memory. Right? The first thing here. The second thing is that all variables share the same name and must be on the same data type. So remember here, I have to highlight something with that one here. Must be on the same data type. It normally apply for many programming language. But in the Python, it's not restricted. You can mix together. It's not only on the same data type in the Python. We'll talk later about the Python. Okay, so think about this one here. If you look on this one, I have the array, and the name of the array here is grade. Grade here, and in that I store for 1, 2, 3, 4, 5 elements. I have a 5 element here. The first element 70, and then 80, 65, and 90, and 100 here. So what happened here? See, they share the same name because all of them grade here. Share the same name, same data type here. All of them integer here, right? And the only difference between them is a subscript or index here. I think about this. This one is number 0. This one number 0. This one number 1, 2, 3, and 4, and so on. You see, share the same name, at the same data type. And the only difference here, it is a subscript, or sometimes they call it index here, the same. When you talk about the subscript or index, is the same. So again, I have the definition about element. Element is an item in the array. So if you look on this array, I have 5 elements. I have 5 elements here, and subscript it is the position number of item in the array. Remember, now I want to highlight here. In the real programming language, the subscript always starting from 0 to come all over to less than number of elements in the array, less than one. I think about this one here. Or this one, you see, you have the 5 element. You have the 5 element in this array here. But in order to access it into the every single element of array, you have to use a subscript here. But remember one thing here: subscript always starting from 0, come all over to the number of element minus 1. It makes sense? Now, starting from 0, come all over to number of element and less than 1 here. Okay? So think about this one here. If I want to do with the grade number 2 here, what do you think? What I have? What grade number 2 here? What do we have? What is it? What's the value of the grade number 2 here? So you have 70, 0, right? 80 is 1, and 65. This one you have 65. You got it? The value of the element with the index number 2 here is a 65. Actually, when we use the number 2 here, it is the element number 3. Make sense?
So
because you're starting from 0.
So basically the number inside of the brackets is the subscript.
Yes.
Subscript is always 1
less than the order of elements.
Okay. Thank you.
Now again, I want to highlight one more thing here. If you work with a real programming language, it always starting from 0 to come all over to the number of element minus 1. But if you work with Raptor, it starting from from number 1. That's the difference between the Raptor and the real programming language. So that's one I want to highlight here. So when you work with Raptor, remember that you have starting from the number 1 and come all over to the number of elements. Okay. Now see, that's the position of item, right? Starting from 0 to 1 less than the number of elements in the array. It always in the whole integer number. And size of the array is the number of elements, right? So think about this one. You have an array grid here, and the size of this one, you have 5 because it can hold for 5 elements. All right. Any questions so far? Okay. And each array element can use the same way as a single item of the same data type, right? So think about if you want to check what is the grade what is the first grade, you have to use grade 0 here. And what do you think? What is the value of this one? What is the value of this one? Grade 3 here. What do you have?
90.
Yeah, great. You have this one here. You have 90 here. Right? So see, when you use the subscript number 3, actually it linked to the element number 4. Make sense? Okay. Okay, so how the array occupies the computer program? It depends on the data type. So think about, in order to store for the integer number, the computer needs a 2 byte. Right? So basically, think about this one. If you need the 2 byte to store it, so this one, if you stand from number 10, this one's to the number 20, 12, and this one 14. That is the order. When it's stored into the memory, it's stored continuously in the memory. Right? And depend on the data type. Now, how can you create and load data in the array? To create an array, you can place the element inside brackets separate by the comma here. So think about this one here. I create my list here. Sorry. For this one here, I create my list. Or you can think about that array. And this one, that's the empty, no element. And this one, I have 3 elements here. And in the Python, I can set my list to 0 and I type 10. That means I have 10 elements of number 0 here. That's what you can do with the Python. What you can do with the Python here. Now, that is the case you use that manually, right? Is that manually to create it? But what happened here if you want to load about grade of 100 students and 1,000 students here? You have to use the loop, right? You have to use the loop here. And basically, you just remember that you have 2 types loop. Right? The first one is it is a definite number iteration. Right? You remember that, right? And the second one is an indefinite number iteration, and you control it by the sentinel value. Correct or not? Okay. You have 2 types loop. Right? You have 2 types loop here. Now, in order to load data into array, you have to think about using loop. That's the first step here. That is the benefit of the array. Right? You have to use a loop here. So it's array with a definite number of iteration. You use a for loop in the Python, and it's array with an indefinite number of iteration. You use a while loop in the Python. And basically, in the Raptor, it's quite the same. But in the Python, remember that I mentioned it on the last slide, right? When you work with the Python, if you work with a definite number of iterations, you use a for loop, and you work with indefinite number of iterations, you use a while loop. Now, let me show you how it works with how to load the data here, right? How to load the data here. Yeah, that is when I work with why I don't have anything here. Okay. So it is a while loop here, right? That is a while loop. When I work with the Raptor, it works quite the same as the loop. The only difference here, you see, the only difference here now instead of stored into the single variable, instead of stored in the single variable, now you store it into separate element of the array. And in order to separate it, you use a counter here. You see, if you have grades, 0, you store it Actually, sorry, interrupter. Remember that interrupter you have starting from number 1. So if you have grade number 1, that means you store the first element, and have a grade 2, you store grade for the second student, and so on. So see, when you see 1, 2, 3, 4, 5, 6, 7, and so on, you think about loop, right? You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. You use the loop. Right? So think about this one here. And the grade of the first student, right? And keep doing it until the user enters the sentinel value here, -1, right? And if not, you just store it here. You got the grade and you store it into the array, right? And increase the counter by 1. And again, move to the next student here. Right? Makes sense. Okay, let's see how it's done here. Let's see how it's done here. I run step by step here, right? So see what happened here. I run it. So I have 60 here. So see what happened here. After this step, see, it only have the array name right here with the bracket here, and the first element 60 here. So now I run it again. Next one here, counter by 1, right? So now counter 2, increase it here, and the 70 here. What happened here? See, it stores the 70. Sorry, it stores the 70 into the second element. They have the same name. You see, they have the same name right here. And the only difference between them is the index or subscript here. Make sense? Okay, and now see, you do the loop, do it again and again and again until he enters the number -1 here. That is you can think about that is the while loop here in the Python. Right? And or you can ask how many students here, right? You can have how many students, and if he enters the number student 20, you can check if greater than 20, exit the loop. That is a definite loop. This one is indefinite loop, right? You keep doing it until he enters the number -1. Make sense? Okay. So you can see it was the same with the Python here. Let me open the Python file here. The Python file here. All right. That is a specific number of element here. Right? You see how many students? You see. Okay, so that is that's enter the number of element array, right? So at the beginning here, you initialize it. You set all of the element is 0 here. You set the thing about if the user enters the number 10 here, right? So we initialize all of the element, sorry, all array with all of the 10 element number 0 here. And then the next step here, you use a for loop. The for loop here is because it's a definite number of iteration. So see, go all over to the number branch of number here, and for each of the number element here, you just get it and store it into the array. That's all. That's what you do with Python. But actually, for this class, you do not have to go in detail about much about the Python. So I just skip it. I do not go into detail here. And you see, you do the same with the while loop here. While. Okay. So see, it's a while loop here. Keep doing it, keep doing it here until he enters the number -1. And for each iteration, you just append it to the array here. So at the beginning you have the 0, and for each one you just append it into the array. Now that's everything about what is array, right? What is array? What is array? And how can you create array, and how you load data into array? So remember one thing here. Whenever you think about array, you have to think about loop. Because you see, you do with the first element, second element, third element, you maintain the counter. And you see, they always have the same name. The only difference here is the subscript or index. That's why you have to think about loop. Make sense? Okay. Now we move to the sum application of array. The most common one is to find the sum and error. The same one is to do the loop. Actually, it's the same as do the loop. You see, you initialize the accumulator, right? Initialize the accumulator here. So for each of the, so whenever a greater than number of students you exit it, but not is that you get the grade for student. You sum it up to the accumulator, and after that you find out what the average is. But the thing is that one here, the only difference between this one with this example with the last example is that you store it into the array name and the index here. That's the difference here. You store it into separate slot memory, continuous slot memory here. Instead of using one single slot memory and it will be overridden. Think about this one here. So first student, the second one, and the third one, and the fourth one, you store it into the separate memory location. But if you use if you do not use the array here, you store it into a single array. Sorry, you store it in single variable here. What happened? 60. Next one, what happened? 70. Next one, what happened? 80. Makes sense? Okay. Okay, so you can see when you work with this one with the raptor here, you can see what happened here. It's very simple. That's program. See, I get the number of students. I initialize the array here, all of them 0 here. Right. So now I maintain the counter. I need to maintain the counter. Why do we think? Why do we need to maintain the counter? To control the loop, right? And store into the separate location here, right? So you can think about this one here. I run it. I run the program here, right? So I run program. Think about again. We have a 3 student here, right? 3 student here. And I have 60 for the first one. And 70 for the second one. And I have 30 for the third one. So now I will have the 3 students, right? That's why I exit the loop here. So what happened here? You see, they stored into the grade array here. Right? Stored in the grade array. The first element, the second element, and third element. They are separate. They are not override each other here. Right? That's why for any time I can come back here. If I want to check what's the grade of the second student, I can use the array name and the index here. And see what happened here. Right on here. So see, I still able to accept the grade of the second student. But if I store into the single variable here, I have no way. Sorry, I have no way to come back to see what is grade of the second student because it will be override. Make sense? Okay. Okay, so basically this one, this abstraction is the same when you work the loop, but the only difference here is that you store it into the separate variable slot, memory slot here. And you can see you work the same. You work the same with the array here. Sorry, with the Python here. Initialize the array, all of them 0. Initialize the accumulator here, and you do that definite loop. Right? You get the grade and store it into the array and sum it up together. That's all. Hello, any question? Any question, guys? Okay, that what you would run with the. That's when you run with the Python here. Right? That's when you run with the Python. Now, the second application is apply the minimum or maximum. I think about you have array here. You have array with a number array, and in that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 element here. They are the number. Now, if you look at the number here, is a number array here. What do you think? What is the maximum number and what's the minimum number? What do you think? What do you think? How will you find out what is the maximum? What is the maximum number? What is the minimum number? What do you think? Tell me, what is the maximum here and what's the minimum here?
32.
Negative. Yeah.
Sorry.
32 and negative 12.
Okay, that's fine. But my question here, how can you find out 32 and how can you find out negative 12? Tell me how.
You can grab an element from the array, compare it to
Yeah.
the others.
Actually, you have the process of comparison. A process of comparison here. Think about it. You just compare. That's the process of comparison here, right? So think about this one here. The same you do with the computer. I think about this one. You only have the 11 element. It's very simple for you, right? But what happens? You have 100 and 1,000. You cannot manually scan it and see what is the maximum and what the minimum here, right? So you need the process. You need the algorithm to do it. So what do you work with a computer here? Sorry. All right. So in order to find the maximum and minimum, the process do the same. Algorithm do the same. You assign the minimum and maximum to the first element. Right? You assign the first element here. So what happened here? I assign the minimum here. At the beginning, I assign number 2 here. The same. And I assign the maximum also. Number 2. Now, when you assign the minimum and maximum for the first element, you do the loop. Now you do the loop. You run it everything from the second element until the last element. Okay. That is the loop, right? So now for each iteration of the loop, you just compare it here. You just compare. If the number less than, you keep the same. You keep the same. If less than, you keep the same minimum. You see, if the number less than, keep the same. Greater than, you change it to the negative 12. Right? Now, less than, keep the same. 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 So at the end, you have minimum here, negative 12. Make sense? Now, how about maximum? Maximum here, again, you compare it. If less than, change it to the greater one. Number 4, right? Number 4, greater than, keep the same. Right? Compare here, less than, change it to number 5. Right? Number 5, less than, change it to number 8. 8 here, less than 32, change it to 32. 32 here, greater than, keep the same. Right? Greater than, keep the same. Greater than, keep the same. Greater than, keep the same. So at the end of the loop, you have the minimum here, negative 12, and the maximum here, 32. Make sense? It do the same. That is the algorithm. Starting from the first element, and you compare for every single element in the array. And at the end of the loop, you find out what is the maximum and what is minimum. Okay? So yes, of course, you can do with the raptor if you want. You can do with the raptor, but for this one, now see, when you assign the maximum, you run the loop to scan from the second element to the last element in the array, right? So see, for each iteration here, you have to do the comparison, right? If the minimum greater than number, so for sure it cannot be minimum, right? You change it to change it the minimum to the number here. And if the maximum less than the number, for sure it cannot be the maximum. You change it to the number, right? So we run it at the end of the loop. You find out what the maximum and what minimum is. So you look on in the Python here. You can do the same with the raptor. Actually, the process you do the same, right? You see, I assign it for the first element. I assign it for the first element. I run the loop here. If greater than, that means it cannot mean I change it to the current number. It's a mark here, less than, it cannot mark. I change it to the maximum number here. And at the end, I can find out what is the minimum and what's the maximum. Make sense? Okay. And you can do it the same with the raptor. Do the same. When you got the input into the array and you assign the first element, you run the loop and you do it the same. So here you can see clearly what happened with this one when I run with the debugging mode here. So see the first step here, right? You have maximum, minimum, all of them number 2 here. That's the first, right? So now what happened here? I check, right? I check again. Now maximum number 4 already. Minimum is the same. So you see, change step by step, right? Change step by step here. So for each iteration here, you just do the comparison. If minimum greater than, change it to the new minimum. And if the maximum less than, change it to the new maximum. Make sense? Okay. Now, the third application here, you can use the array to replace a net addition. Think about, you have the example here. This program, you have the example here. You have the you are work in the HR department, and you need to report how many employees with 0 dependent, with 1 dependent, with 2 dependent, with 3, 4, and 5 here. So at the end, you see, you make a report here. You have 43 employees, 0 dependent, 35 with 1 dependent. Okay, so now you write program for each employee. You ask how many dependent you have, and you add it up to the counter here. So we can think about here. You can do with the application here. In order to do that, I maintain the 6 dependent count accumulator here. At the beginning, I set all of them 0. It makes sense? At the beginning, I set all of them 0. Yeah. So I ask how many dependent you have. So think about for the first one, right? For the first one here, he said that he had the number 2, right? So that's why I increase number 2 by 1. And I asked the other one here, how many employees you have? He said number 4. I increase here by 1. Again, so third one, how many how many dependent you have? Again, he tell number 2. I increase it number 2 here. Make sense? Hello, tell me, it makes sense or not? You got it or not? Okay, right? So instead of 1 accumulator, now you maintain for the 6 accumulator here to store for how many employees with 0, 1, 2, 3, 4, 5. And suppose that you have no employee have more than 5 dependents here. So this program is quite simple, right? You can think about this one here. You work with the net decision here. Now you see, you have the question here, how many employees, right? Sorry, how many dependent you have, and you got you stored in the variable dependent here, right? So now when you got the number of dependent for each employee, you check the condition here. If number dependent 0, increase the accumulator by 1 here, right? If 1, increase the counter 1 by 1, and 2, and 3, and 4, and 5. Make sense? Okay. Now, if you look on this program, what do you think about this program? What is the pro and the con of this program? What's the pro and con? You do not have to talk about pro. I don't see any pro here. What is the con here?
It's large. It's a large program because it has to go through each question of whether or not the dependents.
Yes, that's very good observation here. That's very good observation. Anything else? It's very good observation. Now think about this one. That's correct. Now think about this one here. What happens if you have the employee with the 5 dependent? See, you have to check. See, 5 dependent, right? So we think about this one here. Number 5 here. Check again for this one, not correct, right? Check again for this one, not correct. Check again for this one. Check again for this one. Check again for this one. You have long way down to the line here, right? A lot of processing here. Now that's the first observation. What do you think? What's the other one here? What is the other part? What happened if you have employee with the 6 dependent, 7 dependent? What have to do? You have a long way, right? So actually you have to extend the program here. You have to extend program to check it again if it's 6 or if it's 7, if it's 9, and so on. And what happened if you have the 15 here? Right? So that a program is a program. That is a program, is a program here. See. The first thing is that you have multiple separate input. I see. You have to maintain for the count 0, count 1, count 2, count 3, count 4, count 5. And if you have to employ with the 10 dependent, right? So we have to maintain the 6, 7, 8, 9, 10. That's the first. All right. The second one here, net decision. It looks very, very cumbersome here. All right. You see. The third one, it not scale up to more dependent. So see, if this program, if you have the 6 or 7 dependent, it will not correct here. It's not correct here. And so if you want to print out how many employee with 0 dependent, 1 dependent, and 2 dependent, you have to do with multiple separate output here. See, and again, if you have need to voice 6, 7, 8, 9, 10 here, it's not good at all. It's not good this program here. So now I can overcome some of the problem here. If you look on this one here, if you look on this program here, you see all of them they quite look similar. They quite look similar here. They have a cow. Sorry, they have a cow here. So I think I can use already. Right? I can use it right here. So I put the same. They have the same name cow. I put the same name cow here. So I hate this one. That is the name of array. And that in that array, I have the 6 element. So at the beginning, I just set the cow, or I set all of them 0 here at the beginning. I use array. Now that is the one. That is the one advantage. The second one is that when I work as array, when I want to print out, right? When I want to print out, I can use the loop here. So instead of doing it a multiple separate lines, right? Sorry. I can use the loop here. Now think about this one here. Now you see, I use the array here. I use array because they have the same name. And in that I have the 6 element, and at the beginning I set it all of them 6 here. I see. Now I can declare and initialize all variable in one line only, instead of the 6 separate lines. That is my first improvement here. Right? Now what happened with the second one is that here. The second one is that here. It's better with the declaration and better with the output. How? See, the last one, if I want to print it out for every single one, I have to do the 6 line here. But now I can do the loop. I run it everything from 0 to 5 here. The 0 here. I just do it for one time only by using the loop. Make sense? Now we will come back to this one. Come back to this one here. If I want to print it out, I have to use 6 separate lines, right? But now using the array, I just need to one loop here to do it one time. Okay, that's the improvement. But I'm not satisfied with it. Still really cumbersome with the negative. Now see, if you observe this one here, what happened here? If you look on this one here, what happened here? If you have 0, add it to 0, right? If you have 1, add it to 1. If you 2, add it to 2, 3, add it to 3, 4, add it to 4, and 5, add it to 5 here. So why do we have to break it down to 0, 1, 2, 3, 4, 5? If they follow the same rule. I should think I do not care what is how many number the dependent here. It only follow the same rule, right? It only follows the same rule here. Actually, you have if the number of dependent here, you have a cow. So depend 0 increased by 1, 1 increased by 1, 2 increased by 1, 3 increased by 1, and 4 increased by 1, and 5 increased by 1. It doesn't matter if the number of dependent here 0, 1, 2, 3, 4, or 5. It makes sense? Okay, now see how we do. Okay, see net decision, right? Again, it also see not scale up two more dependent here. All right, now see what happened here. It doesn't matter. It doesn't matter, right? It doesn't matter if number dependent here. So even that it can be 10. It doesn't matter, right? So see, I have the 10 here. I increase the count 10 by 1. That one step only. I do not have to break it down. Method selection here. Make sense? Now see, you can see what happened with this one here. You can see now. Let me show you some about the the Python, you can see what is the improvement here. Directly is the improvement here. So if I do not move that, this one is negative decision here, right? This is it. I have to maintain the separate. I have to do for the negative decision here along always the line here, right? And I have to work with a separate output here. But what happens if I change it to the replace this one here, right? I replace this. This one. Okay, so see. Where am I? Oh, here's this one. So see, on the left here, it's a net decision, right? You see, it's a long way. But when we replace it by I replace the net decision here, it way better here, right? But what happens? What happened here also? What happened with this one if I run on this one here? What happened if I had? Oh, I do not have it. Where is it? Okay, it should be better. I set it somewhere. Okay, so now talking about what I put the number dependent here. What happened? What do you think? If on the left, if I put the number dependent here, number 8, what happened? Number 8, what happened? It only increase to the dependent number 5 here, right? Number 5. So we can see here, number dependent here, number 1 here, right? Makes sense? But what happened here? On this one, it doesn't matter, right? I run it here on this one. I run it here. Number 8 here. So why put it for this one? Oh, sorry, for this one I had to put it. Again. 8 here. Yeah, huh? So see, it scale up well. It doesn't matter how many BT, right? And again, you see, it only do one action only. Right? Instead of check it down the line here, right? Check it 0, 1, 2, 3, 4, 5, 6, 7, 8. Huh? See, you can observe the huge improvement here when you replace this one with the net addition. Right? When you replace net addition by this one. Make sense? Okay. I think you should take a short break and come back after 10 minutes. Okay. So yeah, you can clearly observe what the big improvement here, right? So we see this one here, you have to do a separate variable here, right? And now we have the long net decision here. And for this one here, you also have to print it out in separate variable here, right? And now if you replace all of them to the array, right? You replace all of them to array. Now you just initialize one time, right? Print it by the loop here, print out by the loop. But the more important thing is that you see you replace the cumbersome net decision here, this one here. Right? The whole process of net decision, you just replace it by the single one command here. I see this single one command here replace the whole cumbersome net decision here. So I do hope that when you look in the pseudo code, you see when you look into the flowchart, you can see what is the improvement here. I see you have the net decision here, right? Separate here. Now you replace it, right? Replace it by the one action here only. Right? Makes sense. So now you move to the another application is a searching an array for an exact match here. think about you have the program here, right? You have a program. Sorry, you have a program here. In that, you think about you as a grocery manager, right? You have many items here, and each of them, right? Each of them they have the specific code. Right? Think about specific code here. Think about to make it simple. For this one, you are the grocery manager. You have 1, 2, 3, 4, 5, 6 items here, right? And you store it into the array. You store it in the array. Now, so this program here asks user to enter a code, right? And you have to check if the input code here is valid or not. So what is valid? Valid one is the one who in the valid item here, right? And if think about here, if the user enters the number one, sorry, if user enters the number 108 here, right? 108, it look it up, this one is correct, so it's a valid item, right? But what happened if he enters the number 200 here? 108 is correct, but 200 is not in the list, it's not invalid item, right? And you use that. What is it? Okay, so this program here, right? Customer order an item, right? You have to check if the order item is in the list or not, right? So think about this one here. Very simple program. Alright, so this is a what is it? Item. What is the finish? Okay, now that program again, it's a netted loop, right? Ask user to keep enter ask user to get input for the code. You want to look it up, right? And once he got the number, he do the loop to check it in the side of the valid item or not. Right? So see, this is out the loop. That means keep doing it, keep getting the code until he enter 999 here. Keep doing it. Now that is out the loop and the inner loop here. So when you got the number from the item from the user, that is in the loop, right? So in order to do that, you maintain the flag here. That's a flag. They call it a flag, right? The flag. You set it to no at the beginning. You have not found it yet. You have not found it yet. That's why you set the flag at the beginning. Is no here. No here, and you maintain. You have to tell how many back item. That's why you do the accumulator here. You set the sub equal to 0 and set it outside the loop. Right? So now see. No, sorry, it's not my code. It's my actually the sub here. It is that is starting from the first index, in the array. You got it? Now remember, in the real programming language, the first index always 0. Right? But remember, when we work after, it's starting from 1. Right? So now see. So think about when he enters the number 108 here. What happened here? You set it from the first element. You set it from the first element here. Now check. You run it everything. If you have the 5 element, right? So we check it 0, 1, 2, 3, and 4. That's why whenever less than the number of the element, keep doing it. Keep doing it here. So see, for each iteration of the loop, you check if the item equal to the element in the list or not, right? If it equal, you change the flag here to the yes. If not, just move to the next one here. I see. If not, that means it always no at the end of the loop. But if anytime if you found it, you change it to the y here. That means you found it. So that see for every item, you just do it everything from the first element to the last element. That's all. Think about this one. When you enter the number 108, you have to check is the first element correct or not. Second, the third, the fourth, and the fifth, and do the same. It always have to scan from the first element to the last element. And he found it, tell him he found it. If not, it's not invalid item here. Make sense? Okay. And you can see it here. You can clearly see that when I do with the raptor here. I do with the raptor here. So I see in the slide I have the valid item here. I have the valid item here, and I get it and get the item, the 5 item here. See, I get the flag here, right? Now, if you look on this one here, when I work with router, I have starting from number 1, not 0. Right? I have to starting from 0. So see, you check, it scan all over the item in the list, right? And for each of iteration, it compare to every single one, right? If it's correct, file it. If not, move to the next item here, right? Okay. Think about this one here, right? If you look my program here, in the main here, item here, and think about I have 100 here. 100 no, right? The power is no here, but when I put one away, I have here, right? So I put that. Okay. Makes sense? If you look on the in the flow chart, you can see what happened. That's very simple. If you look on the flow chart, I do the same. Right? That's the outer loop here. Right? Outer loop here. I got the item and the 999 to exit here. So you can see for this one. If you look on my router here. Get that here. Right? Enter 99. Right? And at the beginning, I assign all of the valid item. I so item number 1, 2, 3, 4, 5, 6 here. And when I move to the loop here, in the loop here, I set the flag. I starting from first item and check it here for everyone. Yeah. So at the end here, you have 2 possibilities, right? If the flag is yes, you file it. I print it out. If not, you do not file it here. Huh? Got it? Very simple with the program here. But what do you think about this program? What is the core? What's the disadvantage of this program? What do you think? Any comments?
In the first loop, it has a output that does nothing.
Which one?
On the right side, the item equals valid item sub.
This one?
Yes, no,
This one?
this one.
This one?
No,
This one?
yeah, that one. It doesn't output or do anything.
But you have to do it.
Okay.
Right? You have to do it to keep the file with no here. Right? You have to do it. So you see, if you do everything, if you are not able to find anyone, the file will always stay at no here. Right? You have to do it. Okay. Now, what do you think about this program? Now, this is very simple program. You only have 6 elements here. So what happens? You have 1,000 elements. You only have to scan from the first to the last here. So what happens if you found the item in the second item or the third item? I should expect that you have exited immediately, right? So think about here. You have many numbers here, right? Think about you have 1, you have 2, 3, 4, 5, 6, 7, 8, and so on here. So what happens if I found number 2? I want to exit it instead of doing for every element in the array. This one is it has the problem. This one here. Right? What if the number of items is very huge? It always have scanned from the first element to the last element. Now, what do you think? How can you make improvement here? How can you make improvement? So whenever you found it, you exit the loop. Whenever you found it, you exit the loop. What do you think? You can use a combination here, right? You can use a combination when it reaching to the last element, or when the flag is yes, you exit it. Whatever condition comes first. So see, if you're not able to find it, you run everything from the first to the last. But whenever you found it, yet here, you exit the loop. Right? Make sense? Okay. So we learn it later about this class here. But for now, we know that this is problem here. You have to run it. You have to scan it for every element in the array from the first one. No matter the size of the array, it's a 5 element, 6 element, or 100 or 1,000. You only have to do the same from the first element to the last. Okay, now that is when we look in the pseudocode again. I expect that you have to understand when you work with the debugging exercise here. When you work with debugging exercise here, you have the list. Sorry, you have the list of valid item here. See, you have the list of valid item here. And what else? Okay, so see, that is the loop, right? You got the code for the first time, and you go to the loop file item here. You see, you set the flag is no, set it from the first element, run it all over to the side here. Is that mean it is a number of element? Everything from 0 until the 5. That means every element here. So now check for each iteration. You check if the number equal to valid item or not. Set it with. If no, do not do anything. And you move to the next iteration here. And you see, at the end, you have two possibilities here. If the flag is yes, you found it. If no, it's not found it, and you increase the bad item count by 1 here. And see, that is when you done everything with the inner loop. And in the outer loop here, if you want to move to the next input, you need to get the new input from the user here. The process is do the same. Nested loop here. The outer loop is that enter the code. Keep doing it until we enter 999. And the inner loop, scan everything from the first element to the last element. So here again, I expect that you look into the pseudocode here, you understand the logic. In order to do with this, in order to work with the debugging exercise. Okay? Any question? Any question?
Do you expect us to have it exit early?
Not for this one. Okay? We'll talk about later this one. Okay? Always check for every single element in the array. It's not efficient with the list many items. And I think the Python works the same. Let me see what is the Python. Yeah, so basically the Python, if you understand the pseudocode, the Python works exactly the same. You can convert from the pseudocode to the Python. Right? Now we talk about how to exit early later. Now we talk about using parallel array. I expect you understand about the process, about the logic of the parallel array here, because we will do it a lot with the final project and the final setting. So parallel array, what is a parallel array? Parallel array is a 2 or more array with the same size. Now you have to think about, it's very important thing here. Same size. What is same size? That means same number of elements. Right? Same size, that means the same number of elements here. Okay. Each element in one array is associated with another element in the same relative position here. The same relative position in the other array. Right? For example, we have the item number and the its price here. Now think about this one. They are the parallel array here. Sorry, they are parallel array here. The one is a valid item, and the second one is a valid price here. Now see, they have the same size. 1, 2, 3, 4, 5, 6 here. They have 6 elements. Right? Now each element in one array is associated with another element in the same relative position. So if you look at this one here, code 106, you know for sure the price here 0.59 because they are related together on the same index here, right? See, what's the price of 405? You have a 1599. Right? So see, they are associated together by the same relative position, or getting by the same index here, index or subscript. Make sense? Make sense or not? Okay. Now think about this one here. You had the customer order an item, right? The program check the item is a valid item in the list or not. The same with the last one you do, right? So whenever he enters the item, The first step here to check if in the list or not. If in the list, you will print it out. What's the price? And the reason you are able to print it out the price because they are related together. I think about this one here. Think about if what happened here. If the user enters the number 108, right? Now we do the scan. You do the process of scan here. Scan it, and you know that the second element here, it is 108. So if you want to find out what's the price of the 108 here, you move to the second element in the price and you print it out 0.99. Make sense? Okay, so we see the first process here. The outer loop here, it do the same. It keep asking user to enter the number of items here, until he enter 99 here. So the outer loop the same, right? Agree or not? The outer loop is the same here. So what happened with the inner loop here? Is an inner loop here, and the only difference here in the beginning is because instead of only one array, now you have another array. They are parallel because they have the same size and they are related together. Make sense? Okay. So now see what happened here. The process works exactly the same. Set the flag here. No. Starting from the first index here. Scan it. What happened here? Whenever your item found it, you found it. So what happened? You found it. You know for sure what is the index here. So it might be the first index, the second index, the third index. And because when they are related together, they have the same index here. Right? The user print it out. What's the price? Make sense? Okay, so we see the only difference here that user print it out the price here. And the reason you are able to print it out because they are related together with the same index here. And you see the remaining of them the same. The process the same. Make sense? Okay. So again, if you look on the serial code here, again, expecting you to do the same, right? You have the one array, the second array here, the same, right? The outer loop here, do the same, right? The outer loop is the same. Keep doing it until he enters the 99. The inner loop here, exactly the same. The only difference here, see? The only difference here is that print out the price here. See? And it's highlighted here. So this program and the previous program is exactly quite the same. The only difference is that you have another array and you print it out what is the price of the related item here. You see, you can clearly see here. When you found it, right? When you found it here, yes. And you know for sure what is the index here. So think about you run it, right? You know that you have 108 here. You know that is index number 1, starting from 0 here, right? So we print out what's the price of index number 0. Number 1. It is 0.99 here, and you are able to print it out 0.99.
So it basically just saves that number from that.
Yes, right. So whenever you found it, you only have the number of index. You have the index number, and you just print it out the price because they are related together.
So what that line is doing is just basically saving 0.99.
Print it
to
out.
the variable price.
Print it out, not save it. Print it out.
That's not an output.
This one here, right? Yeah. Sorry. Yes, it's my correct. So you see, you have the variable here, and you save it into the variable price. Right? And yes, the output here. Sorry. Yes, the output here. You print it out. Yes, correct. Okay. Any question about this one? Okay. Okay, the same, right? This is the same. This program also, you always have to check for every single element in the array. What happens if you have array with 100 or 1,000 elements? You have to do the long way here. Now, how to improve the search process here? That's what I mentioned here, right? The program should stop searching the array whenever match is found. Right? So if not found, of course, you have to run everything from the first to the last element. Right? If not found, but what happens if you found it on the second or the first or the third element? You expect that program exit it immediately. Right? So how we do it here? The larger array, the more benefit you have. So see now, you use the combination the condition here, right? Either look it from the first element to the last element is the case you are not found it. But what happened here? If you found it on the second or the first or the third element, you have to found it more yes here, right? And you check the condition here. If found it is equal to no, that means yes here, right? You exit it, you exit it here. And of course, when you exit, you have two possibilities here. Either you are not able to find it, you already run all the way, and you're not able to find it, right? And print it out here. Not able to find it, and bad item is number one. If not, if yes, that means you already able to find it, and just print it out the prices. Make sense? Okay. Okay, so let's see. When you convert it to the serial code here, it works exactly the same. You only need to change the condition here. Right? Either condition comes first. Right? So if the sum is less than the size and you have not found it yet, keep doing it. Right? But whenever you run it all the way, you are not able to find it, exit it. Or whenever you found it, yes, here, you exit it. Right? So see, when you compare it here, when you compare this one here, you only have one condition here. When you run all over to all of the element in the array, but when you compare to this one, you have two conditions here. Here, you have two conditions here. Whatever condition comes first, you exit the loop. Make sense? Okay. Now that one also very common application. Very common application when work with the array here. That is searching an array for the range map. You expect to do this one with the final project. Programmer want to work with the range value with the array. Think about 1 to 5 or 30 to 30. Now the most common example is that you got the discount percent. I think about if you buy, it depends on the quantity you order. So if you think everything from 0 to 8, you have no discount. But if you order everything from the 9 to 12, you have 10%. From the 13 to 25, you have the 15%. And you have the 26, you have the 20% discount. So you can think it's quite simple, right? If that work with array, with as many elements as possible, and you order quality, you can think about here. You have the discount, and you have the 76 element. I think about this one. As element 0, that means no quantity, right? That's the quantity. You have the 0 here, that means you have the one quantity, right? And so on here. So see, you can matching this one here. You can matching with this one here, right? From 0 to 8 here, 0 to 8 here, you have no discount, right? See, 0 to 8 here, no discount. And from the 9 to 12 here, you have 0.1 discount and so on. What happened with this one?
It's large.
Yeah, and what happened if he ordered 100 and 1000? You also have the 1000 element here, right? You have 1000 element here, and you have no idea how many items here he can order. 10,000. What happened, right? So that is a huge problem with this one here. Right? Let's see. That is a huge problem. This one drawback of this approach here require very large array and a loss of memory and store the same value repeatedly. Let's see. Remember, in order to store value, you need a slot memory, right? So the more element you store, the more memory it is. And you see, it stores the value the same repeatedly here, right? And how will you know when you have enough? What happened if you order 1000 or 10,000? Right? Okay. The better approach here, you create the two parallel array. Now I want you to understand about the logic here because you will use it in the final project here. And in the better approach here, you create the two parallel arrays, each with the 4 elements. You think about this one here. And one array has the 4 discount rate, and one array has the low end. Now, remember this one have low end. You have to remember this one have low end of each quantity range here. Now think about this one here. I have discount 4 here, 4 elements, right? 0, 10, 15, and 20 here. And see, array have the low end of quantity here. That is the low end here, right? That's the low end here. 9 here is the low end. 13 here is the low end. And 26 here, low end. Make sense? So see, whenever you see, whenever you have is range from 0 to 8, you have 0. When you have the from the 9 to the 12, you have 10% and so on. Okay, that is the first step. You have to understand about that. When you work with the range math here, now whenever we work with the range math, right? When you work with the range math here, you have to think about you work with the parallel array. And one array has a discount rate, and one array has the low end of the each quantity range here. Now, what happened next? What happened next here? How can you do it? You can think about you can use the netted decision. You can use the netted decision here. See, check here. If the quantity greater than quantity limit number 3, that means greater than 26 here. 26 here. So you just print it out. 0, 20 here. Sorry. So netted decision work. Of course, it works. Check it here. You know for sure. You check it. You know for sure it works here. But it's not scaled well here. I have another better solution here. Now think about this one here. You can use, instead of using the netted decision here, you can use a loop to make a comparison. So how it work here? Now, how it work here? So basically, you can see that I have the range here. Sorry. Yeah, you can think about this one. I have the range here. I have 0, I have 9, I have 13, I have 26. Now, how can I do with the loop here? How can I do the loop here? I starting from the last element here. I starting from the last element. That's why I have x equal to sign minus 1 here. Because in the real programming language, use the last one is that the number of elements minus 1. You got it, right? So sequence this one is 1, 2, 3, 4. So actually it's starting from the 3 here. Starting from 3 here. So see, starting from 3 here, I check if the quantity. If think about if I enter the number 50 here, quantity here, I got the input. What happened here? If the 50 here, right, less than what's the x now 3, that means if the 50 here less than 26. No, right? No, you exit the loop, right? And you know for sure the discount here, the x here number 3, that's the discount here. It is a 0.20. Got it or not? Starting from the largest one. And there's a 50 here. 50 not less than exit the loop. And I take the index number 3. I take it discount number 3 here. I have 0.2 here. Now that is the case when I enter the number 50 here. What happened? What happened if I enter the number 12 here? Sorry, 20 here. What happened? If I enter the number 20 here? Now see, starting from the largest one here, right? The largest one here. So the quantity I here number 3, right? So see, again I check here, 20 less than 26. Correct. Correct. That means I have to shape it back. I cannot do it, right? So yes, I have to minus it x by 1. That means I have to shift it back here. Right? So I have moved to the second one here. I have to check it's the second one here, right? Now for the second iteration, Now you see, -1. So you see at the beginning you have the 3 here, right? So after the first iteration, now x is number 2. Now x number 2 here. Now you see, I check again. Number 20, I got it. Less than the quantity number 2 or not? Less than 13 or not? No. Huh? No, I exit it. I print out this count here. This count I here number 2. So I see that is a 50 here. Make sense? That's all. You do everything you think about this one. 0 here. 9, 13, and 26, right? Check about this one. Check about this one. If it's greater than, you have 0.2 here, right? If not, move to about how about this one? If greater than 13, you have the 0.15. If not, move how about this one? If correct, you have 0.1 here. And if not, have 0. That's the process. That's the process here. So now, the only thing I want you to understand about the process, you have to understand about the process. About this process. Sorry, about this process. That's all. I expect you to understand about the process. Now again, let me explain it again. It is quite, I see that some of you, it's very hard for you to understand how this is. But when you understand the logic, it's quite simple. Okay, remember that I have 2 variables right here, right? So for this one here, I have 0. This one I have 0.1 here. This one I have 0.15 here. And this one I have 0.2 here. Now see, I starting from the largest one. I got the input. Whatever I did. I don't know whatever input it is, right? Maybe the 20 or maybe 50. Now I always have starting from the largest one. Starting from the last element here. Of course, this you can think about it's a highest element. But some case it can be from the first one. So think about in the case you have the grade 90, you have the 80 and the 70. You have starting from the first one. It depends. But for this one, you have starting from the largest one. So see, when it's starting from the largest one, you have starting from the last element here. The last element. You know that when you have the sign -1, that is last element. Got it or not? Yeah, because the element always starting from 0. Index always starting from 0. Right? So with the sign -1, that means the last element. So think about this one here. Whenever he have to enter the 50, greater than correct. That means he have that number x here, keep the same, number 3 here. That's why he have 0.2. If not, how about this one? Of course, when you check how about this one, you have to move to the second element. Second to the last. That's why you have to minus each one. Make sense? Okay, I expect you to got the idea of this one.
How does it know when to exit?
Whenever you end, now see, oh yeah, that's a good question here, right? Now think about this one here. Let me do it here. Okay. All right. What happened here? You have 0, you have 9, you have 13, you have 26. Now, what happened? If I enter the 50, I sit here, right? If I enter the 20, I sit here. If I enter the 15, I sit here. 12, I sit here. Whatever. Whenever I enter anything from 0 to 8, you exit it. That's all. You always have the action to exit the loop for this one. Now think about this one. What happened if he entered 8 here? Now look at this. What happened if he entered 8 here, right? Now check. So for the first one here, not correct. -1. So X now number 2. X now number 2. Now check it. Move to the second one. Move to the second one. Not correct. Not correct here. Not correct. Not greater than 9, right? So minus, you have number 1 here. Now, I check again. The quantity 8 here less than 9. That is the correct. So again, move it to the next one. That is the last one here. You always have the condition to exit the loop. You always have the condition to exit loop because the last one is 0 here. When you enter, you always have to enter the number greater than 0, right? Okay, make sense? Yeah. So you always have the condition that, let's see, whatever it be, you always have the condition less than quantity limit 0. That means less than 0. Less than 0 here. You cannot have any number less than 0. That's why you have no here. And you exit the loop.
And the reason why you can't have anything less than 0
Yes.
is because that is the number
Of quantity
of the
you order. Yeah.
in the array. Okay.
That is, yeah, you see, the quantity order here, whenever you enter the quantity order, it must be the positive number, right? And you cannot have any quantity number, negative number. That's why here, when you go all over to the number 0, right, you have no way to less than 0. No way to less than 0. That means no here. No here, that means exit. And exit, that means here. At that time, you have 0 here. Right? At 0 here, what is it? No percent. No discount. Make sense? Okay. This really long lecture. So, and a lot of the application, but it's very useful in the programming here. So I hope you expect the process this one. Now, okay. So you see, when you convert it from the pseudocode here, from the flowchart here, when you work the pseudocode, you see, instead of working with the netted decision, right? Now you work with the away loop here. You see, that's the loop here. Set it from to the last element, right? And every time check it, right? If less than correct, that means it cannot be true, right? You move to the left here, right? And when you exit it here, you have to keep the same act here. When you got it from the loop, after the loop. So now, when you look on this process, I do hope you understand about the process. That's all. Now I can run it in the Python. You can see what happened. And run it in the Python. You can see what happened with this one. Now let me run. First, what happened if I enter the number 50 here? I put the number 50 here. Okay, so we see the size here is a 4, right? 4 element here, right? So now we run it here. What is the act now? Right? You can see act now is number 3, right? Act now at the beginning is number 3. That means the last element here. Now we check what's the quantity. Quantity 50 here greater than quantity limit. Does that mean number 3 here or not? You see, look at this one. This one, right? 50 here. Not less than 36, right? Not less than 36. So that is a true. That means, sorry, a quantity here not less than, that is not correct, right? Not correct. Yeah. Now let me explain it again here. Now think about this one here. When you enter the number 50 here, right? When you enter the number 50 here, you check. Act now is number 3, right? So what is the quantity limit? Act number 3. That means the 26 here. Right? You got it? So now see, 50 less than 36, not correct. Not correct. Skip the process of the loop. Right? And just print down here. Discount act here. That means 3. That means you have 0.2. Right? Make sense? Now, see what happened here. See, skip it, I print it out here. Alright. See, this correct is 0.2 here, right? So now I do another one here. I do that one. Enter now. This time I enter the number 22. The process is the same, right? You see at the beginning quantity here, starting from number 3 here, right? Now what happened? 20, right? Less than 26. Correct, right? So when you correct, that means you have to minus 1 here. You have to minus x1. Now see, x now number 2, right? So when you move next number 2, So we check the quantity less than one limit 2 here, that means 30 here, right? 30, 20, less than 30, no way, right? No way, that means you exit the loop and it brings out this curve here, 0.50, right? Make sense? Okay. Okay, so again, the best way you do with the pseudocode that you have to understand the logic here. And in order to understand the logic, you look in the you can look it in the flow chart. You can look it in the flow chart, or you can look it in the pseudocode. And see, when you understand about the logic, you can convert it into the Python, right? In the real programming language, very simple. Now, I believe that is the last one, 2-dimensional array. Right? So you can think about you have many students in the class here. Right? You have 1, 2, 3, 30 students in the class, and each student you have the 5 text here. Each student you have the 5 text here. So you can think about this one. You can do the loop, right? That is a netted loop. That is netted loop here. The inner loop is that you run everything from the test number 1, 2, 3, 4, 5 for one student. So when you're done with one student, you move to the next student, and so on. And I give you the example with this one already. What's this one? You can store for this one. Now, about the list in the Python. Actually, in the Python, they have no definition for array. They call the list, but they work the same as array. The only difference is in the list in Python is that it can hold for various type data. But normally for other programming languages, you have to be on the same data type. But in the Python, it can be various. It's not fixed. You can add it, remove it, or whatever it is. And you have many functions with build function here. You can append it, extend it. You can get the index, the pop. I will give you the example with this one later. I think on Thursday. So I think that's all for today. It's a long way, but I do expect you that you understand about the logic here. So after this class, I will send you the slide for this one, and I hope that when you look in the slide, you will have better idea about how it works. All right? Okay. Any question? So again, I strongly recommend that you have to look again the slide and look again about the homework assignment. What you have with the adapter, what you have with the pseudocode, and what you have with the Python. And you can raise any question to me on Thursday. Okay. Any question, guys? I know it's a long lecture here, but I hope you have studied awake and understand the logic here, because you see you will got it you will get it in the final project and the final exam. Any question?